You know that simple one-line import statement we all type a dozen times a day? Yeah, it looks pretty harmless. But behind the scenes, it's kicking off this whole complex operation with a surprisingly deep and fascinating secret life. So today, we're going to pull back that curtain and see what's really going on. Right? We use it constantly, almost without thinking. But what's actually happening when you type import pandas or from my app import utilities? Let's dig in and find out. Okay, so before we dive into the really deep mechanics, let's just get the basics straight. We got to start at the tip of the iceberg, and that means talking about modules and packages. These are the fundamental building blocks for pretty much any organized Python project. At its heart, a module is just beautifully simple. It's a Python file, that's it. Any .py file you create is a module, all ready to be imported so you can reuse its code somewhere else. It's the most basic Lego brick in our toolbox. And this is how we scale up. When you have a bunch of related modules, you group them together in a directory. And voila, that directory becomes a package. This is what lets you build really large, well-structured applications. Now, you've probably seen that special _init.py file. For a long time, you had to have it to signal to Python that a directory was a package. It's technically optional in modern Python, but you'll still see it everywhere. So why even bother with all this? Well, it all comes down to some really smart software engineering principles. First, reusability. You're not copying and pasting code all over the place. Then there's maintainability. Trust me, fixing a bug in one small module is way, way easier than in a single gigantic script. And this last one, namespace isolation, is absolutely critical. It means the helper function in your utils module won't ever clash with a different helper function from some third-party library you're using. Okay, so you write import my module. How does Python actually find that file on your computer? It's not like it scans your entire hard drive, right? That would take forever. Instead, it kicks off a very specific orderly search, which I like to call the Great Module Hunt. And this hunt follows a strict set of rules every single time. First, Python looks right where you are, in the current directory where your script is running. This is why importing a file right next to your main.py just works. If it's not there, it checks a list of custom directories in your Python path environment variable. And if it still can't find it, it looks in the standard library, where all the built-in goodies like math and os live. And here's the really cool part. This isn't some hidden abstract concept. You can actually see this exact search list yourself. Just import the sys module and print out sys.path. It'll show you a list of every single directory Python is going to search in the exact order it's going to search them. You'll probably see that the first item is an empty string, which is just Python's way of saying the current folder. Now, when you're importing your own stuff inside a big project, you've got two main choices. On the left, you have absolute imports. These are the recommended best practice because they're totally unambiguous. They spell out the full path from the root of your project. They also don't break if you move files around. On the right are relative imports with the little dots. They can feel shorter, but man, they can get really confusing about where exactly you're importing from. Now we get to the really clever part. Think about it. If Python had to do that entire module hunt every single time you imported something, our programs would be incredibly slow. But it doesn't, all thanks to a powerful and often overlooked caching system. I absolutely love this quote from a Reddit discussion because it just perfectly nails the nuance here. The import statement itself does run every time you call it, but the expensive part, finding the file, compiling it, executing the code, that only happens once. So how does that work? The secret is another part of the sys module, a dictionary called sys.modules. Before Python even thinks about starting the module hunt, it checks this dictionary. It's basically a cache, a speed dial list, that holds a reference to every single module that's been loaded during your program's run. And this is the key. If the module you're asking for is already a key in that sys.modules dictionary, Python just grabs the existing module object and is done. The whole process stops right there. This is why modules in Python behave like singletons. No matter how many times you import a module across your project, you're always getting back a reference to the very same object in memory. It makes every import after the first one almost instantaneous. Of course, no system is perfect, and one of the most common, most confusing errors developers run into is the dreaded circular import. Let's break down what that is and, more importantly, how to fix it. Ah yes, the classic circular dependency. Look at this. Our models.py file needs to import a function from services.py, but Services.py needs to import the user class from models.py. So Python starts to load models, it sees the import and says, okay, hang on, I gotta go load services. Then it jumps to services, which tells it, hey, go load models, and Python just throws its hands up because it's already in the middle of loading that file. It can't resolve the loop, and you get an import error. So how do you break the cycle? Well, the best, most robust solution is to refactor your code. Usually, this kind of error is a sign that your code's architecture is a little tangled. A quicker fix, sometimes called a lazy import, is to just move the import statement inside the function that actually needs it. This delays the import until the function is actually called. And if the dependency is only for type hints, there's a really clean modern solution using the typing.typi cching block. But hey, understanding the import system isn't just about fixing errors. It also opens up the door for some serious performance optimizations and even lets you extend Python's core behavior. This is the fun stuff. Here's a situation I bet a lot of you have seen. You build a command line tool, but even running a simple command like -help takes a few seconds to load. Why? Well, it's often because your script is importing heavy libraries like pandas or TensorFlow right at the top of the file, even when they aren't needed for that specific command. And this slide shows the simple, elegant fix: lazy loading. The eager approach on the left loads pandas the second the script starts, but the lazy approach on the right moves the import inside the function that actually uses it. This is a total game changer for startup.com. Your script starts instantly, and the performance hit is importing that big library is only paid when and if that process data function actually gets called. And for the real power move, you should know that Python's import system is completely extensible. You can actually hack it. There's a thing called sys.path, which is basically a list of Finder objects. By creating your own custom Finder and adding it to this list, you can create import hooks that literally teach Python how to load modules from anywhere. A database, a network URL, a zip file, you can completely override the default behavior. So as we've seen, that humble import statement is way more than just a way to access code. It's a sophisticated, high-performance, and fully customizable system. It's a core part of what makes Python so dynamic and powerful, which kind of leaves us with one final provocative question. Knowing that you can change the very way Python finds and loads code, what would you build?